Hey everyone, welcome back to the lab. In this video, I'm going to be introducing 1000checkboxes.xyz, which is a real-time, globally synced display of 1000 checkboxes. And I'll show you what it looks like in a minute. So a few weeks ago, I stumbled upon 1000checkboxes.com, a website that syncs 1 million checkboxes across the internet. And if you haven't seen this, I think it's like really fun and cool. Oh, it doesn't look like it's working right now. Okay, it's working, but it's really, really slow. But anyway, you like check these boxes and you can see everyone else checking boxes and look how fun it is, how many boxes are moving around. And this was fun, and it inspired me to want to build something too because, I could. It seemed like a fun build. I was bored, and I wanted to try to build it with HTMX and see if I could do it in a few hours. And so I built it. Here we'll dive into what it is, my clone of 1 million checkboxes, and how it's built. And so you can try it now at checkboxes.xyz, and I'll give a little demo in a second. So what is 1000checkboxes.xyz? Basically, the primary experience is a big list of 1,000 checkboxes, similar to 1 million, but we only have 1,000 here. And then you check a box and it gets sent to the server, and then your web page is going to pull the latest list every few seconds. Now, the syncing only happens every few seconds via polling, so it's really near real time, but truly all real-time systems are actually near real-time systems because of physics, so it's close enough. All right, and I'll do a little demo here. So I'm going to open this up, and I'll have it in 2 tabs, and I'll refresh both of these just so you know that it's like live. And basically it just syncs, right? So I'm gonna do this, and it's gonna sync over there. And then I can go over here and do this, and it'll sync to the other side over here. And yeah, it's a little slow. It's not maybe quite as fast as 1 million checkboxes, but it does the thing. So now let's talk about how it's built. So I had 2 ideas I wanted to explore with this build. The first was, how would I build this with HTMX? 1 million checkboxes is definitely a spa using sockets, but I'm interested in HTMX. How might I do this with it? And then I was also interested in, can I build this in a few hours? I've been thinking more about this, how in order for things to be like fun builds for me, they need to be kind of fast and not take forever, because then I'll just lose interest. And so this idea of building in a few hours, max like a weekend, is really appealing to me to kind of keep some of this interest going. And now in the end, I was able to build and deploy this with HTMX in about 6 hours. So I think it was largely a success on these fronts. Now I improved my odds by sticking with technologies that I'm familiar with and loosening requirements to fit my parameters. I really like the idea of an innovation budget where it's like you can and should explore new things, but if you explore new technologies, then that means exploring less of a new domain. And here we're kind of building something new and trying to use HTMX in a way I haven't used it before. And so I wanted the core to be something familiar with, so that wouldn't get in the way of doing this build. And this is really like the whole idea around simple scalable systems, to find solutions that find a balance between the values that matter to you and an attractive compromise. So here we build a foundation of a simple scalable system so that we can grow from there to try out those new things. And so here I chose to use the Ham stack, which is how I'm building most of my projects these days, and get a head start with that with Cloud Seed, which is my F# project boilerplate, which gave me a ready to build full stack web app. So I could just go ahead starting building the web page and the backend and stuff like that. So the tech stack itself is this. The front end is server-side rendered HTML via F# and giraffe.view engine with a little bit of HTMX sprinkled in, really just around that grid because that's what needs to be updated. The backend is F# and Giraffe. The DB, there really isn't one. All the data is in memory, which we'll talk about later, but this is very simple and quite scalable. And finally, for hosting, I'm using serverless containers on Railway. Railway is a kind of newer hosting platform that I've been experimenting with. I haven't made a video on it yet, but I've been having a good time so far with my side projects. And you can learn more about how I built with this stack in these posts here. This one's about F# and HTMX. This one's about F# and giraffe.view engine to build HTML via an HTML DSL. And then this one's about F# and Giraffe itself for building a backend web API. All right, a few interesting challenges. So this build had a few interesting challenges, many that forced me into certain suboptimal solutions due to my choice of HTMX, both because of its features and kind of how it works, but also my skill with it. So if I were building this like in prod and this was like making me money, probably would have maybe chosen different solutions and maybe even different technologies to build this. But given my constraints, I had to work around a little bit to build it quickly and cheaply and stuff like that. Now, I like building side projects with HTMX, but one of the downsides that I've noted is that it's often not the right choice for things that need constant client updates like video games. This is because HTMX sends its front end from the server, so if you're constantly updating the client, this means lots of network usage, which is often one of the slowest and most expensive hops in a web app. And this is often one of my biggest gripes with people moving to microservices in order to achieve greater scalability. What they're often actually doing is causing every flow to now have additional network hops in the middle, which is one of the most expensive things it does. And so often you're making everything a lot costlier, not actually more scalable. But I digress. And so the first challenge with this is around global replication and syncing, because we need to be able to sync the checkboxes to everyone's web page. How do we do this efficiently? So if you look at what 1 million checkboxes does, it's basically a spa that loads on the page, opens a socket, and seems to get updates from the server when a checkbox is changed. Now, given our experience just using it before, I think it's also doing some weird, other stuff, because I would have expected me to be able to click the checkbox immediately and then that gets synced. And so it seems like there's probably more processing happening here that maybe is not something I would have done. But generally this seems to be what it's doing. And this is how many real-time apps work, as sockets are both fast and lightweight. Maybe not lightweight on server, there's ways around it, but keeping open sockets can be heavy usage of a finite resource, but it is often lightweight in the fact that you only need to send data that's been changed, because you kind of have an understanding that the setup's already taken place if this socket has been opened already. And so obviously this leads to when things are changing a lot, this leads to the ability to send sparse updates as opposed to full updates, which can really lower the bandwidth required to send that. And because networks are the most expensive hop, really lower usage of that bottleneck. Now, HTMX might be able to do this streaming diff thing. I don't know, I'm a noob, I've never done this, but it does seem rather complicated, as you would need a way for it to both get streamed HTML and enable it to identify the single checkbox that was updated. I feel like this is probably possible with the use of sockets, HTML IDs, and a streaming change pipeline, but I haven't done this before, and this is probably outside of the scope of what I want to do, because it would probably take me more than a few hours. This is probably a heavy burden on my innovation budget for this one. So this is something I think probably could happen, but I just wasn't the right time to look into it. But if this gets a lot of usage, maybe I will. And if you've done it, let me know how you've done it before, because it seems like a fun thing to explore. So instead, what I did is I just opted for a simpler polling approach, where HTMX just polls for the updated checkbox grid periodically, which gives it a near real-time sync while working with very simple and common request response patterns. You ask for the grid, we give you the full grid back. Of course, this polling approach does mean sending the whole checkbox grid on each poll, which leads to potential bandwidth problems at scale. And so this is kind of where that SPA approach with sockets is probably way better in terms of bandwidth usage, and probably is one of the reasons I chose 1,000 checkboxes instead of 10,000 or 100,000, because sending that grid would probably be too large for this approach to kind of work, at least without the streaming optimizations. Okay, so dealing with HTMX network bandwidth. So one of the benefits of the SPA socket transfer is it can send just the diffed data, which is probably pretty small. If I was doing this, I'd do something like an array of indexes to check and uncheck, which is probably a few bytes. And I guess if you're really streaming it, you could even just send the individual checkboxes that are changing and just pipe them through. And if you really didn't care about consistency, you could probably just send them like that. That would be pretty lightweight. And then it's okay if a front end misses a message or something, because who cares? So that's probably a big benefit of that approach. Now, HTMX is sending the whole front end though, so it at least is sending the markup for an individual checkbox, if we were streaming diffs, but in my case is sending all 1,000 checkboxes each time. And so this streaming approach, even if you can do the streaming approach, it's not going to be a few bytes. It's probably going to be many bytes, because we have to send all of that HTML. Now, on investigation, this payload for the 1,000 checkboxes grid came out to about 45 kilobytes uncompressed, which is reasonable for a periodic update. This is why I think people's saying that HTMX is too slow or whatever doesn't really make sense, because like at most you're probably changing a small part of the page, and let's just say it's even 100, 200 kilobytes. Like it doesn't really matter if you're submitting a form or like this update only happens on a user action. It's still going to be pretty fast and be pretty unnoticeable. But if you are doing this thing that's more like a video game where it needs to happen like every few seconds, this latency and payload does start taking a bigger effect. And so this is why I always say like HTMX is maybe not the best approach for these things that need to update a lot. And so in our case, we're doing this every few seconds for every single user. And at 45 kilobytes, that's not bad for one page load. But if every user is now doing like 10, 20, 100, 1,000 page loads, this quickly gets out of hand. And this is a quick way to basically explode the bandwidth usage and incur runaway cloud costs, which I would personally like to avoid. And here's a horror story about that, or something similar happening to this developer side project where they racked up a $100,000 cloud bill on Netlify. So to deal with this, I implemented ASP.NET standard response compression. F# Giraffe runs on ASP.NET, and so we basically get everything that they're using for free. And this was actually really easy and effective. It reduced my payload to about 5 kilobytes, even with all the Tailwind and HTMX tags, which is a great way to increase the size of your HTML, which gives us about a 90% win for like literally, 4 lines of code. So it's still larger than it could be, larger than it would be if we were using sockets, if we were using this kind of client-side state idea. But it is small enough that I don't need to worry about it melting my bandwidth too much. But, please be nice and don't DDoS my side project. All right, and so the next challenge is like handling server load. So most of my projects get like 0 server load because no one uses them, but I always like to think about this because it's fun and I want to avoid ridiculous runaway cloud costs so that this hobby remains fun instead of leading to financial ruin and a lifetime of regret. And, everyone always thinks this won't happen to them, but then, every week we get a story of like someone's stupid side project running on serverless, just costing them like, tens of thousands of dollars. And so to handle this, I decided to set up like the simplest, most robust thing I could that would get close to the UX I wanted. I'm cutting corners here. It's not quite real time. It's not quite the same experience that you get on the other websites, but it does the job and it's relatively scalable for the values that I care about. And basically this thing just runs on a single server that has a max capacity set and it goes to sleep if no one is using it. I really like serverless containers that scale to 0 because my projects get basically 0 server load. And so this means that I'm not paying for what I'm not using, but I can keep them online for like a very long time and people can still check them out when they're ready to. And this means that if it gets too much load, it will just die instead of costing me money, again, preventing these, unbounded runaway cloud costs. Now, this single server approach brings with it some nice benefits that are both simple and scalable. The first is that I can use an in-memory database. I use a single array of 1,000 items to store this data structure, which is very fast and memory efficient. If I tried to do some like horizontally scaling, this wouldn't work so well because they wouldn't share that same DB without me like doing some other stuff. If I was doing that, I'd probably like use a Redis or a Postgres or something like that. The next is caching. I use a single cache, again, because it's just one server, so we know that that is the globally replicated cache. And I don't really need to worry about this replication. It caches the most expensive thing in this case, which is really the output grid HTML. So by doing this, I'm caching, any operations I'm doing on these 1,000 items, but also the transfer into my intermediate state, but also the transfer into the actual output string, which is really the heavy area of this whole operation. And so that saves as much compute as it can. Theoretically, this is scalable, of course, but I don't actually know until it's in prod. So, go give my website a hit and let's see how it works. Now, personally, I don't expect this to actually need these optimizations, but it was fun to work for, and it has them if it needs them. And this 1 million checkboxes guy, like his server is like burning down every week or so. And so I'm trying to save myself the trouble if it ever gets close to that. Next. So I thoroughly enjoyed building 1000checkboxes.xyz for fun. Sometimes I get caught up in like the indie hacker, capitalist, New York mindset of like everything needing a purpose and that purpose being money and impact and career and stuff like that, which often kind of robs the joy of building. And I enjoy building, so that kind of sucks. So sometimes it's nice to just like take a step back and build stuff because you want to, which is a lesson that I'm continually relearning, year after year. If you liked this project, I have a few others that are similar, totally useless, but doing an oddly specific thing. Time Drip basically syncs everyone watching it on a little globe you can look at. Time Tick is literally showing you time tick away, and smash the button allows you to smash a big counter that is also globally replicated. If you like this post, you might also like the HAM stack, a simple scalable tech stack for building modern web apps fast and cheap, which is kind of my philosophy of how I'm building web apps these days, both in my side projects, but also honestly for companies and stuff. I think this is a pretty good simple scalable system for building most systems. Might also be interested in how to build a full stack web app with F#, which kind of combines all of my tutorials on different parts of building web apps with F# into one, so you kind of have a good paved road for how to go from 0 to something. And then finally, you might be interested in my 4 side project income sources, a breakdown if you're curious, like if any of these side projects make money and kind of where it's coming from. That's it for this video. Thanks for watching, and I'll see you in the next one.